Hello everyone, welcome to today's class. In this lecture, we'll discuss conic section. The subtopic for today will be parabola. Okay. The theory part of this, as such, is pretty long. The questions will be easier if you understand the concept. Otherwise, you can see in front of you there are 4 different shapes. Each different shape has a different equation, and then the characteristics vary accordingly for each one of them. So you cannot learn 4 different shapes and their characteristics. If I give you like 5 important points for each shape, then you'll have 20 points to remember for this parabola only. Same goes for the upcoming topic for ellipse also and your hyperbola also. So you have to understand how a parabola effectively is working. Okay. Let's see first of all how we define a parabola. So remember how we used to define circle. Circle was basically all the points, collection of all the points, and there was a fixed point known as center, and the distance from of the point, moving point P, and this fixed point was same. So this time this is your fixed point. Okay. This F. Okay, right now forget about what is A, what is B. Right now this is the fixed point. Okay, fixed point. Let's first understand and then we'll talk about that. Now you try to take any point. Okay, you take any point such that the distance of that particular point from this point, okay, from this fixed point focus, and the distance of that point from this line, okay, distance of a point P from this focus and distance of the same point P, okay, perpendicular distance from this line. These two distance must be equal, PF, P, let's say M. Okay, so the idea is that in order for to get us the shape of parabola, the idea is that PM and PF, they must be equal. If we collect all the points which satisfy these condition, means the distance of the point from focus, okay, that fixed point right now, okay, fixed point, and this line, okay, if that is equal, it's called parabola. The collection of all the points is known as parabola. Okay, all right, let's erase it now. We'll start with the basic equation and the most important one also, y square equal to 4ax. The moment you get parabola word around it, the first equation that should pop up in your mind is this, y square equal to 4ax. Okay, this is the shape of it. It's a this shape, this one, okay. U kind of shape. Okay, this is our fixed point known as focus. Okay, this particular point about which this parabola is turning, okay, is known as vertex. Right now its origin, it's called vertex. Okay, and then we have a line known as directrix. Okay, so these are few words that we have to look for: vertex, focus, directrix. Okay, these are the keywords. Okay, I'll discuss only the first parabola, okay, so that the remaining you can understand accordingly. Okay, this is something you have to accept. Okay, don't we can derive how this equation comes, but right now I'm not going into the derivation part. Okay, so if you have a parabola, y square equal to 4x, right now consider that only as your equation. Forget about these three. I'll talk about these three later. So the first thing that we have to talk about, I'll have to create a table now. Let me create it. let's create it like this for now. All right. So first point, vertex. Vertex is the point about which the parabola is turning. This point, oh, I was talking about the origin. Okay, so the vertex is 0, 0. I'll write everything with black. 0, 0. Second point we have to consider is focus. Okay. So the focus is right now a, 0. Remember that the distance of focus from the vertex is always a, means this distance is always a. You consider this, that the focus and vertex, they are at a distance of a, and right now it's on the right side. Okay, so that the coordinate will be a, 0. Okay, this is 0, 0. All right, next we have to talk about is directrix. Okay, equation of directrix. So this line that I was talking about, no, like you consider any point, so distance from focus and distance from this line, so that line is known as directrix. Okay, and again the directrix is also at a distance from the origin. So the focus is also a distance, directrix is also at a distance. If focus is on the right, directrix has to be on the left. If the focus is on the left, directrix has to be on the right. So it is a line parallel to your this is y-axis, or as such you can think of like this is parallel to your parabola as such, kind of parallel, not exactly parallel. Okay, so any line which is vertical in nature, will be, the equation will be given by x is equal to something. Right now it's a distance towards the left of origin, so the equation is x equal to minus a. X equal to minus a. Fourth, equation of axis, also known as axis of parabola. Forget about everything right now, just focus on this figure. If I talk you about this parabola, the yellow one that I highlighted, it is drawn symmetrically about x-axis. Okay, so x-axis is called your axis of parabola. Okay, so what is the equation of x-axis? If the parabola is around x-axis, it's going around x-axis, so the equation of x-axis is y is equal to 0. Equation of y-axis is x equal to 0. This is something we have covered in straight line also. All right, so the axis of parabola is known as the axis about which this is drawn. Okay, not the axis which it is touching, not the y-axis, but the axis which it is in between the parabola, or you can say it is the axis on which the focus will also lie. So focus is on the x-axis, so your x-axis is the axis of parabola. Then there is one word known as lattice rectum. Okay, length of lattice rectum. Okay, I'll show you what's lattice rectum in this same parabola. I've highlighted that also with red. Okay. Let's highlight with green. Okay, you can see in this green color line. Okay, if I draw a perpendicular from this focus, the length that is covered here, this length is also a, this length is also interestingly a. You can see how this a parameter is very important. Okay, a is some number right now, don't worry about a is some number. So a is the distance of vertex and focus, a is the distance between vertex and the directrix, a is also the distance between the focus and this point just perpendicularly above the parabola and below also. This total length, if I call this as, let's say, point A, point B. Okay, so this lattice rectum is AB. Okay, so from this figure, what can you say? A above, A below. So the total length of this is 2A. Okay, so my bad. This is not A, this is 2A, 2A, not A. 2A length above, 2A length below. So the total length is 4A. 4A. Length of lattice rectum is 4A. And last point, focal distance. Focal distance is distance from focus basically. Distance from focus of any point x comma y. So in this scenario, suppose you take any point on this parabola x comma y, and how do you calculate distance from focus? Using distance formula. If you calculate that and you use this condition that y square is 4ax also, combining those two conditions, you get this as a plus x, and my recommendation is learn these. Okay, learn all these conditions. Okay, what is your vertex? As such, vertex can be anywhere, but this particular equation, first of all, learn this equation, y square equal to 4ax. Learn this. For this equation, vertex is at origin. Okay, a is the parameter that will tell you a lot about your parabola. It will tell you where is your focus. Focus is inside this parabola. First of all, if this is the kind of shape, it will be present inside this. Like if this is a circle, you will say center is inside it. So if this is a parabola, focus will be here inside it, somewhere like that. Okay, so learn these parameters. What is the vertex? Where is the focus? What is the equation of directrix? What is the axis of parabola? Axis of the parabola is about which it is drawn symmetrically. Okay, now that I have covered the first one, this was for y square equal to 4ax. We can create the same table for minus 4ax also. So what happens? Y square equal to minus 4ax. If this is the kind of equation, what do? You draw same thing. It's just that do the mirror image of it about x, this y-axis. Means the parabola first was on the right. Now you draw it on the left. Okay, you can see this is still the same shape. The axis is still x-axis. It's just that we have inverted the shape. Now focus will be on the left, directrix will be on the right. This distance will be still a. This distance will be still a. The distance above and the distance below will be 2a, 2a. Okay. So that's pretty much you have to remember. Okay. And vertex is still the origin. So I'm creating the table, but you don't have to learn it. You just learn for any one. And for the remaining, what you can do is improvise accordingly. Okay. So then we have to talk about again y square is equal to minus 4ax. Okay, so the second shape I'm talking about now. Okay, first one is done. Second, the parabola can be on the left x-axis. Okay, so this time everything will be mirror imaged. So the vertex is still the same, so no change here, 0 0. Okay, now you can see focus is towards the left, so distance is still a, it's just that towards the left it will be minus a comma 0. Okay, minus a comma 0. Directrix will be on the right at a distance a, so this time change it, instead of x equal to a, it will be x equal to plus a or a, I'll just say. Okay, axis of parabola is still the same, it is still symmetrical about x-axis. Okay, it is symmetrical still about x-axis, which is y equal to 0. Lattice rectum still 4a, it's a length, lattice rectum is length, so that is still 4a. Focal distance, instead of a plus x, it will be a minus x. All right. Now once you understand first two, the remaining are pretty easy to understand. Now, this time the parabola is on the y-axis, you can see it's drawn symmetrical about y-axis, left side of the y-axis and right side of the y-axis. Okay, so that kind of equation, it becomes x square equal to 4ay. Again, learn it. Either it will be y square equal to 4ax or x square equal to 4ay. Okay, how do you know then what kind of shape it will be? I tend to do it like this, like if it is the power of x, or the minimum power, which has minimum power in this, in the first expression, which has the minimum power x, so that means it will be drawn about x-axis. In this one, which one has the minimum power? Y, so it will be drawn about y-axis. Okay, so this time it will be drawn about y-axis. Again, the distance of focus will be a, and below it, okay, because we are dealing in y-axis, so below it will be your directrix at a distance a, and it will be parallel to the parabola or parallel to this x-axis. Okay, kind of parallel. All right, vertex is still 0 0. Focus is on the y-axis above x-axis at a distance a, so it will be 0 comma a. Okay, and your directrix will be below it. Okay, so it is first of all parallel to x-axis. Parallel to x-axis, the equation is y equal to something, so it will be y equal to, because it is below, it's minus a. What's the axis of this parabola? Y-axis. The equation of y-axis is x equal to 0. Okay, this is the axis of parabola. Okay. Now lattice rectum still the same thing, it's just that lattice rectum now it will be drawn like this. Okay, 2a, 2a, so still the total distance will be 4a. Okay, and your focal point will be a plus x, instead of x now it will be y. Basically x and y are being interchanged here. All right, lastly x square equal to minus 4ay. Okay, now again with the effect of negative, what does a negative do? It's just doing mirror image of it about the axis. It was above x-axis, now it will be below x-axis, like that. Okay, still the same thing, distance, this one is a, this one is a, this is 2a, 2a, so lattice rectum will be still 4a. Vertex is always 0 comma 0. Okay, for these equations, I'm not saying it cannot be anything else, but for these equations vertex is 0 0. And now focus is below, so it will be on y-axis, so 0 comma minus a. Okay, so if you remember, like focus is at a distance a, and you know the shape, you can pretty much guess whether it will be plus a comma 0, minus a comma 0, plus 0 comma a, or minus 0 comma a. Directrix will be above it, so parallel to x-axis, y is equal to something, y equal to a. Axis is still y-axis, which is x equal to 0. Lattice rectum doesn't change, the length is still 4a, and instead of plus, now it will be minus a minus y. Okay, focal distance. This is which is supposed to be learnt by you, but you can see how much information you have, right? 6 points I have discussed, 4 shapes are there, 4 different equations, 24 points to learn. Don't learn it. Try to understand, try to get to the level where you can write these conditions as per your understanding. I'll tell you with the help of questions how we can use that. I'll mostly relate it with y square equal to 4x or max to max x square equal to 4ay. For negative, we'll always just do the mirror imaging. Okay. So something you should know that what is the shape of this parabola, where it is opening. It's opening around positive x-axis, it is about negative x-axis, it is about positive y, it is about negative y. And the focus is in between the parabola. That's it. Rest everything we can figure out from the question. Let's see the questions now. You'll be able to understand more. Again, learning these equations will help you because these are the standard shapes which will be used in your integration also, and some parts of differentiation maybe. But application of integration, AOI, that is area under graph, there these equations are pretty much standard. Differential equations, differential equation uses these equations again, family of parabola. So you are expected to know the equation of parabola is y square equal to 4ax, the standard parabola. Okay. All right, let's see first question. He is saying find the coordinate of focus, axis of parabola, equation of directrix, and length of lattice rectum. Okay, I think the easiest part is length of lattice rectum. Let's see the first part. He is saying y square equal to 12x. First of all, we'll compare it with y square equal to 4ax. Okay, what is your a? If you compare it, 4a is 12, so a is 3. Okay, just for our understanding, let's just roughly draw this parabola. Y square equal to 4ax, it will be something like this, and the focus will be here at a distance of a, which is 3. Directrix will be here at a distance of 3. Lattice rectum is 2a, 2a, and that means 6, 6. Okay, that will be your directrix. So let's see. We should have drawn something different. Anyway, focus is what's our focus? It's here. This is the focus at a distance of 3, so 3 comma 0 or a comma 0 directly you can say. Then directrix, first he's asking for axis of parabola, axis of parabola. One second, I'll just create a sort of table so that we don't have to write everything over and over again. All right, he is asking for focus, axis of parabola. I'm writing only PR. Okay, equation of directrix. Okay, and length of lattice rectum. Okay. I can write LR, lattice rectum is LR. Okay, So the first part we have done, we have roughly drawn the shape. We can see it as at a distance of 3 comma 0 on the right. So focus is 3 comma 0. A is 3 na. Identify A and write everything else accordingly. This parabola is on which axis? This axis, which is this x-axis, that is y equal to 0. Then equation of directrix, this is our directrix here. Okay, it is parallel to y-axis. How do we write any equation that is parallel to y-axis? X is equal to something. What is that? This is on the left of origin. Okay, so x equal to minus 3. If it was on the right, plus 3. Lattice rectum is 4a, that's 12. Okay, interestingly, you can directly say that this factor, the factor that is written with x or y, is always the lattice rectum. Okay, directly you can say that. Okay, second part, I'll write the final answer here, just drawing the shape. For second part, x square equal to 4ay. First of all, x square, power, whose power is less? Y power is left. So it will be on y-axis like this. Okay, focus will be inside it at a distance of a comma 0. So what's our a? First let's identify a. We should have identified a first. X square equal to 4ay na. So 4a is equal to 6, x is equal to 3 by 2 or 1.5. Okay. So this distance is 1.5. So your directrix will be below like this at a distance of 1.5. All right, let's see. The focus is above, this is the origin na, x-axis, y-axis. So focus is above 1.5 distance. So the coordinate will be 0 comma 1.5. Okay. See, I'm not using now this table as such. This table was from understanding point of view. I'm just saying, I'm plotting this, that this distance is a, this distance is a, and writing accordingly. Axis, what is the axis of the parabola? It's drawn symmetrically about y-axis. What is the equation of y-axis? X equal to 0. No need to learn. Equation of directrix, this is the directrix. I'm drawing it with this color. Okay, this is parallel to x-axis. So basically y is equal to, what is the distance? 1.5, but it is below, so minus 1.5. Okay, y equal to minus 1.5. All right, lattice rectum, that's 4a. That is always, you can directly tell lattice rectum, their coefficient written here, that's 6 directly. Third part we were doing. Okay, third question. So for third one, he's saying y square equal to minus 4a, minus 8x. So y square, first of all, which power is less? X power is less. So it will be drawn on x-axis. But because it is drawn, it is written minus 8x. Okay, this is minus 8. So it will be drawn towards left like this. Okay, focus will be inside the parabola at a distance a. 4a is 8. Just don't get a as negative. First of all, my recommendation is like y square, compare it with minus 4ax, and this is minus 8x. So by comparison, you will still get 4a equal to 8, a is equal to 2. Get your a positive, because the negative and positive, it is changing the shape of the not the shape of the parabola, but the orientation, whether it is on the positive x-axis or negative. Okay, so the distance is 2. Directrix will be also at a 2 distance here. Okay, the directrix is this one at a distance of 2. This is the origin, y-axis, x-axis. Now you write accordingly. What is the focus? Focus is on the left of origin at a distance 2. So 0 comma minus 2. Okay. Axis, it is drawn on x-axis. So y equal to 0. Okay. If you want to see this, for this axis, it is symmetrical. So that's why it is called axis of parabola. Then he's asking for directrix na. So this is the directrix. Again, it is parallel to y-axis. Parallel to y-axis equation is x equal to something. What is this? 2, and it is on the right side, so plus 2 or 2. Okay, if it was on the left, then negative. If it is on the right, plus 2. And lattice rectum is the coefficient. Forget, don't, while considering the length, we don't consider negative, so just this length, that's 8. Okay. So lattice rectum is easy to identify. Directly you could see the coefficient of x raised to power 1 or y raised to power 1. Okay. And for which axis you have to draw the parabola, that can also be considered by power 1. Whatever power is 1, you draw x parabola on that axis. Okay. All right, let's do few more to have a better understanding. Right now, the equation is given to us, and he is asking for us for the conditions or the focus, directrix. He is asking the information out of the question. The second type of questions arises like that, in which information will be given to you and you have to create the equation of parabola. Okay, we'll see how to deal with that. Okay, first 3 done, next 4, 5, 6 we have to solve. Fourth one, I'll shift this slightly on the right. Fourth one, x square equal to minus 16y. First of all, y raised to power 1, that means the parabola has to be drawn on y-axis like this or below. Because of the negative, it will be drawn below. So this is the parabola. So focus will be present here, f, at a distance a. So let's calculate a. X square equal to minus, compare it with minus 4ay is equal to minus 16y. So 4a is 16, a is 4. So this distance is 4. So the directrix will be above it, parallel like this. Okay, also at a distance 4. Okay, this is the directrix. Let's write down the focus. Fourth part we are doing. Focus is at this is origin na, x-axis, y-axis. So focus is below x-axis at a distance of 4. So it will be 0 comma minus 4. Axis of parabola, this is our axis, which is y-axis. The equation is x equal to 0. Equation of directrix, parallel to x-axis, y is equal to something. What is that something? It will be 4 and plus 4 because it is above, so plus 4. Below it will be minus 4. So y equal to 4. And lattice rectum is directly the coefficient here, that's 16. Let's see the next part, fifth. The next one is y square equal to 10x na. So again, x raised to power 1. So the parabola will be on x-axis. Okay, so let's roughly draw it. And since it is positive, so it will be drawn on positive x-axis. X-axis, y-axis, origin. Focus will be inside at a distance a. Let's get the a. You know, like 4a has to be compared with 10. So a is 10 by 4, which is 2.5. So this distance is 2.5. Directrix will be here like this at a distance of 2.5. Okay. Lattice rectum, directly I'll write 10, the coefficient itself of x. Focus is at on the right. So the coordinate of this will be on the x-axis. It is 2.5 comma 0. Directrix is on the left, parallel to your y-axis. If something is parallel to y-axis, it will be x equal to something. And since it is on the left, not right, so it will be minus 2.5. Okay. Left is negative, right is positive. Up is positive, down is negative. Okay. and the axis of parabola, this is the axis which is x-axis, so y equal to 0. Next, sixth, last one here, x square equal to minus 9y. Okay, directly, first of all, now I'm writing very much direct here. The coefficient, just the number, not the negative sign, is lattice rectum. Let's finish that first. Lattice rectum is 9. Okay, now let's compare. 4a is 9, a is 9 by 4 or 2.25, your call. Okay, power is 1 for y, so it will be drawn on y axis. So either it will be like this or it will be like this. Okay, because it is negative, so it will be drawn below like this. The focus will be at a distance of 9 by 4. The directrix will be above at a distance of 9 by 4, and it will be drawn like this. This will be the directrix. Okay, here this was the directrix. Okay, so the axis of parabola, we decided now that it will be drawn on y axis. So axis of parabola is y axis or x equal to 0. Okay, focus is at 9 by 4 distance below the origin. So on y axis it will be 0 comma minus 9 by 4, because it is on the y axis itself, na? So x coordinate has to be 0, and the directrix will be parallel to x axis is y equal to something, that's 9 by 4, and it is above, so not negative, it's positive. As simple as that. I haven't used directly this table. I just used this condition that the distance of directrix and the focus is a. The lattice rectum is just the coefficient of this x or y, and it is length, so it has to be positive. But the idea is like the lattice, this point focus, if we take perpendicular distance above and below, it will be 2a 2a, or in this scenario right and left, so 2a 2a. Okay, all right, we've covered these. Now let's see the questions here. For these questions, what you have to do, you have to write the equation of parabola which satisfy these conditions. Okay, so now he's saying focus is 6, 0. Here it is focus. Focus always lie inside the parabola, and it is on the x-axis, so it has to be like this. If this is the shape, what is the equation? Y square equal to 4ax. Now you need only the shape and what was the equation. That's the key part. If focus is here, the equation is y square equal to 4ax, and this distance is a. So a is 6. The coordinate is a, 0, or a is 6. So now we know the equation is y square equal to 4, a is 6, x. So basically 24x. We don't even had to use this equation. The directrix, we didn't even need that. Okay, it's very much common sense that the focus lie inside the parabola. So parabola has to be drawn like this. Okay, if this is the focus, can you draw parabola like this? No. It's the standard parabola. If you draw like this, the focus is not inside, so not this shape. Okay, all right, so just one condition I used. And see, the important thing is like you have to find only a. You have to know the equation and you just need to find a somehow. That's it. Let's see. Next is, he's saying focus is 0, minus 3. Now you tell me 0, minus 3, it will be here at a distance of 3. Okay, it is minus 3, sorry, 0, minus 3. So this distance is 3. If this is the focus and it is inside the parabola, how will you draw the shape? You'll have to draw the shape like this. Okay, something like that. X-axis, y-axis, x-axis, y-axis. And if this is the kind of parabola, first of all, it's on the y-axis. So the equation for this is x square equal to not 4ay minus 4ay, because it is drawn inverted. 4ay is above. Okay, so this is the equation. All I need is a. You know, a focus is at a distance of a, so your a is 3. So just put down a as 3, minus 4, 3y, minus 12y. all you have to find is A and judge the equation first. You should know the shape and the equation. So from this table as such, the importance is for these equations, like for which equation, what is the shape. I'll draw it with a different color. One second. You should know the equation and you should know the shape. By looking at the shape, you should know whether it is plus 4ax minus 4ax, plus 4ay minus 4ay. Okay? That you need to learn, not the table itself. Let's see ninth one. He's saying vertex is 0, 0. We know the standard vertex is always 0, 0 for all that. And focus is again 3, 0. 3, 0. I think pretty much same as the 7th question. If the focus is here, it has to be inside the parabola. That means parabola has to be like this. And if it is this parabola, it is y square equal to 4ax. That means we need only a, this distance. If this point is 3, 0, this distance is 3. And this is your a. That's it. 4 into 3 into x, 12x. As simple as that. 10th one, same idea. Vertex is 0, 0. We know it's okay. Focus is minus 2, 0. Minus 2, 0. It will be drawn here. Minus 2, 0. That's your focus. If this is your focus, how will you draw the parabola? You have to draw like this. That's the only way it will contain this focus. So now let's write down the coordinate. This is minus 2, 0. That means this distance is 2, which is our a. And what is the standard equation of this? Instead of y square equal to 4x, this is y square equal to minus 4ax. A is already we have calculated, it's 2. So minus 4 into 2 into x minus 8x. Done. As simple as that. 11th one. This time we'll have to read the condition. Vertex is 0, 0. Okay, fine. That means we have to use these equations only. Okay. Passing through 2, 3. So it is saying that the parabola is passing through 2, 3. And finally the most information came. The axis of parabola is along x-axis. That means parabola, my bad. That means the parabola is drawn on x-axis. So on x-axis, either this way we can draw or this way we can draw. Okay. So in both the scenarios, tell me 2, 3. 2, 3 is in the first quadrant. Here it is 2, 3. This is the only way the point will lie on this parabola. So that means this cannot be the parabola, because the point has to lie on the parabola. If this was the parabola, on the left one was the parabola, how can 2, 3 lie on this parabola? It cannot. That means we have to consider this kind of parabola, and we know this is a standard one, y square equal to 4ax. But this time he has not given us anything about focus anything, because majority of question that we have done is using focus. But how can we calculate? If this point is lying on this equation, it has to satisfy this equation. So let's solve it. Y is 3. So 3 square is 9 is equal to 4ax is 2. Okay. So what do we get? We get a as 9 by 8. Okay. So y square equal to 4ax. Put the value of a. A is 9 by 8. So basically 9 by 2x. If you put a as 9 by 8, the equation will become 9 by 2x. So this is the answer. This is the equation he was asking. I'll repeat the idea again. We got two options. It was saying that the parabola was having axis as x-axis. So these two are the only option. But if we consider the second one, not the first one, The problem is this parabola cannot have a point 2 comma 3 because it's in the second and the third quadrant. How can 2 comma 3 will lie on this parabola? So we rejected this, hence we accepted this, hence this is the equation, and now we have to find a, and 2 comma 3 will satisfy this equation. Any point satisfy on any curve, it has to satisfy its equation. If this point was on a circle, it will satisfy the equation of circle. If this point was on the straight line, it will satisfy the equation of straight line. Done. 12th one, let's do 12th one last. Okay, he's saying vertex is 0 0. Okay, passing through 5 comma 2 like previous one. Okay, symmetric with respect to y-axis. Symmetric with respect to y-axis means basically indirectly again he's saying that the axis of parabola, because how I define axis of parabola? How did I define? It is the axis about which it is symmetric. Now he is saying it is symmetric about y-axis, so it has to be like this or it will be like this. These are the only two options. But again 5 comma 2 is lying in first quadrant somewhere here, let's say. That means the above one has to be the correct parabola, so we reject this one. Let's remove it. And what is the equation of this one? X square equal to 4ay we have to consider. Thought process is more important here. Rest everything is same. Put the value of y and x in it. X is 5, so 25 is equal to 4a, y is 2. So a is coming 25 by 8. So the equation is x square equal to 4 into 25 by 8 into y. So x square equal to, solve this, 25 by 2 y. That's the answer. Okay, fine. I hope this much is clarified here till this. We just covered parabola. After this we'll do the remaining two shapes, that's ellipse and hyperbola. Okay, so remember that although I have drawn this table for your convenience, you cannot learn all these directly. Like you cannot mug up, and you shouldn't mug up. More importantly, you should understand the way I taught it. It's very much simple because right now you have only one parameter a, and I told you how to approach that. Focus distance is a, directress distance is also a. Okay, and just use that. Whichever power is less, you'll draw the parabola on that axis. Learn the equations. Y square equal to 4ax, it's on the right. Y square equal to minus 4x, it's on the left. X square equal to 4y, it's upward. X square equal to minus 4ay, downward. Learn that. That's okay. Okay, so I'll end the session here. Okay, see you in the next class. Good day everyone. Bye.